Welcome folks. Today we're going to be talking about quadratic equations. And the first one we have here is a situation where we've got a linear equation intersecting with a quadratic. And there's going to be some different situations that go along with this kind of question. And basically what's going to happen is, number one, what if this had a actual variable in it? If this was y equals 4x minus 6 instead of mx minus 6, then I could actually find out where they intersect. If it intersected once, if it intersected twice, or if it never intersected at all. I could figure that out because I would just solve this using a system of equations and it would give me the x values they have in common. In this case, though, what's happening is, and don't get me wrong, you could get asked that. But in this case, what's happening is that they're giving us an equation with a variable in it. And so we can't make them equal to each other and solve them as a system of equations because we have too many variables. We wouldn't be able to actually solve it. But what we can do is we can use discriminant. So what's important to remember is that the discriminant is b squared minus 4ac. And then when the discriminant is equal to 0, well then what we're talking about is its tangent touching one time. And when the discriminant is greater than 0, whoops, let's make this greater than. Greater than 0. Then what's going to happen is it's going to touch twice. And when it's less than 0, then it's not going to touch. And then I guess the other possibility is that if the discriminant is greater than or equal to 0, then it touches or intersects once or twice. Okay, so typically in this kind of scenario, what's going to happen is that if I go ahead well, let's go ahead and set it up. If I go ahead and because this is y, and what we're talking about is where they intersect, this y should equal that y. And so what I'm going to do is I'm going to take this and I'm going to replace that y with it because, again, it should be equal. And so if I write the equation mx minus 6 is equal to x squared minus 4x plus 3. Well, now what I can do is I'm going to go ahead and get everything on one side. I'm going to treat it like a quadratic, like I was going to try to solve it. And typically when we solve a quadratic, we try to make it equal to 0. If I subtract mx on both sides, and add 6, mx, add 6. What I'm going to have is I'm going to get x, or 0 is equal to x squared, and then this minus 4x minus mx, and then plus 9. Now, this is what throws people a little bit sometimes, and what's really important to remember is that when we have when we're talking about the discriminant, because clearly at this point, hopefully you can see, there's no way for us to solve this, okay? Because I've got two variables. I've got an x and an m. And so there's no way for me to solve it the way it stands right now. However, if I rewrite it as a discriminant, well, the discriminant, remember now, a is anything multiplied by x squared. And then b is anything multiplied by x. And c is anything not multiplied by x or x squared. So first thing I would suggest, even if you're really good at it, is that you go ahead and you figure out what your A's and your B's and your C's are. Now, what some people do, and it's not a big deal, but if you take a look here, if I take these two and factored out the x, hopefully you'd be able to see that this is going to end up being negative 4 minus m times x. And see, then we'll keep the rest of it the same. And see, when I do this, then it becomes really obvious that a is equal to 1. Because that's the only thing times x squared. And then b is going to be equal to negative 4 minus m, because that's what's multiplied times x. Again, doing this move is not required. You could get that by looking at that. Like I said, anything multiplied times x, negative 4 minus m. And then c is going to be 9. And so all I got to do now is fill in my discriminant. And so b squared, that's going to be negative 4 minus m squared minus 4 times a, which is 1, which I'll write, but it's not necessary because we multiply by 1, we just multiply by 1, and then times c. All right, now keep in mind, because this is tangent, the discriminant is going to equal 0. Now, it's not because the quadratic equals 0, it's because this is tangent. If this problem had said they touched twice, well, or they wanted to know what the value of m is where it touches twice, well, then what we would have to do is make it greater than 0. And then it said, if the same exact question said, find the value of m where they don't touch at all, well, then we would make the discriminant less than 0. So anyway, all we're going to do now, well, I tell you what, why don't you go ahead and pause this and see if you can't figure out what m is, and then start back up again as soon as you're ready. All right, so hopefully you did that, and if you did, hopefully you got something like this. If I squared this binomial, this is going to be 16 plus 8m plus m squared, and then minus 36 equals 0. And so then when I rearrange this in descending order, I'm going to get m squared plus 8m and then minus 20 equals 0. And then all I've got to do is factor this, which it's a pretty easy one to factor. I've got m and m, two numbers that multiply to get to 20 and subtract to get to 8. That's going to be 10 and 2. This has to be positive, this has to be negative, and again they equal 0. My m's could be negative 10. My m could also be positive 2. Now, in any problem on the exam, I also always want to make sure that I always go back to the question when I think I'm done and make sure I've answered it. Find the possible values for the constant m. Okay, we did do that. But notice it also says to find the corresponding coordinates at which the line touches the curve. And see, we did not do that. And sometimes what happens is people get in a big hurry and they move on and they miss valuable points. So let's go ahead and do this. Basically, I mean, if I knew what m was, I would, and again, so if it's negative 10, I would replace this with a negative 10 up here. And then, but at the end of the day, I don't have to go and start all over again. I can just use this equation right here. All right, so what I'm going to do then is, let's draw a little arrow and see, let's say that m is negative 10. So if m is negative 10, what I'm going to get is x squared minus 4x minus and then negative 10 times x plus 9 equals 0. So what I've got here is I've got x squared, x squared, and then negative 4x minus, and then m is negative 10x plus 9. And see, now all I got to do is solve this. And what I get is negative 4x plus 10x. I'm going to have x squared plus 6x plus 9 is equal to 0. And then when I factor this, x plus 3, x plus 3, one of my x's is going to be negative 3. So what I want you to do now is I want you to take the 2 and I want you to substitute that back into this quadratic. Pause it and then tell me what you get. And start back up again. Okay, so hopefully you did that. If you did that, hopefully you ended up with roughly the same kind of thing. It's going to be x squared minus 4x, but it's going to be minus 2x plus 9. And so this is going to be x squared minus 6x plus 9 equals 0. I'm going to get x minus 3 times x minus 3. X is going to equal 3. And keep in mind, they asked specifically for the coordinates, so I still haven't answered their question yet. They want to know the y values that go along with these. And what I'm going to do is I'm going to plug it into the easiest one. I'm going to plug it into the linear equation. I'm going to avoid plugging it into this one. So like I said, in the situation where the slope was a negative 10, that's going to be y equals negative 10x minus 6. And in the other situation, y equals 2x minus 6. And all we got to do then is plug these in. So go ahead and pause that and figure out what our y values are going to be. Okay, awesome. Hopefully you did that. So if I plug this in here, this is going to end up being a 30. Negative 10 times negative 3 is positive 30. Positive 30 minus 6, that's going to be a 24. The y that goes with a negative 3 is going to be 24. And if I put a 3 in here, well, that's going to be 6 minus 6, or 0. So then the y that goes with this is going to be y equals 0. So I find the possible values of m, and I've found the coordinates of the points at which the line does touch the curve on those two values of m. Okay, hopefully that was a good experience for you. Let's go ahead and try this one. Oh no, I tell you what, I always forget this. Let's look at the rubric. So again, notice the rubric here. What happens is that you're going to get a method point for gathering up these terms and making these two equations roughly, essentially equal to each other. All right. Now, then you're going to get a method point for using the discriminant. Okay. And again, you need to be using values that make sense from what you wrote up in the step above. If they weren't exactly correct in the step above, you could still get this method point. Now, if this a point, well, this needs to be, you need to get this. So you end up with this times this. You end up with m is equal to 2 or negative 10. And basically, they tell you what we should be looking for. I need to see this work here. I mean, again, not necessarily exactly like this, but I need to end with this is going to get you a point by having both of those written down. And then when you substitute both their values, your m's, into the equation, then that's going to get you a method point. And once again, as you can plug it into the equation, even if it was wrong, you could still get the method point. And then after that, well, now it has to be this. I need to find out that the x is -3 or 3, and then I need to find the coordinates, which means I find the y's. So in this problem, it's worth 6 points, and you can see if all you had done was find m, you'd only get 3 of them, and you would lose the other 3. It's always really important. Cambridge, on these Cambridge exams, what happens is sometimes they lead you down a path, and you just part A, part B, part C, and sometimes they kind of flow. And then sometimes what happens is they just give you one question with multiple things in it, and it's really important that you don't miss it and that you get all the stuff. All right, so let's take a look at this one. On this one, believe it or not, this is essentially the same question. It's just taken up a notch, and they made it a little bit easier because you don't have to find the coordinates. We're still talking tangent, and again, if you can remember what I said before, anything, I mean, this is a quadratic. Something's being multiplied times x squared. Yeah, there's a lot of variables here, a lot of k's, a lot of values we don't know, where the last one just had the 1m. But we're basically doing the exact same thing. These two guys are going to intersect. And based on what they're telling me, they're going to touch at one point. So we're going to make these equal to each other. And then we're going to get everything on one side. And then we're going to plug in the discriminant. So what I want you to do is first set them equal to each other and try to get everything on one side. And then start back up again, and then we'll make sure we're on the same page, and then we'll go further. Pause it and start back up again when you're ready. Okay, so hopefully you did that. And again, I know it looks a little bit crazy, but what we're talking about is going 2k minus 3 x squared minus kx minus, and you know what? In this case, I'm probably just going to go ahead and distribute this. So this is going to end up being minus k plus 2, just because that's just extra. We don't need that. And I'm going to make it equal to 3x minus 4. And again, I'm trying to get everything on one side. I'm going to try to keep this x squared positive because that's what I like when I might have my quadratics. So what I'm going to do is I'm going to subtract 3x and subtract or add 4 to both sides. So then it ends up looking like this. 2k minus 3 times x squared. And see, now I've got my minus kx, and then I've got a minus 3x. Okay. And then I've got a minus k, and then I'm going to add 4 to both sides, so then it's going to be plus 6. All right, so what we got to do now is and it equals 0, because we got everything on one side. All right? So once we've got this, now what we're going to do is we're going to set up our discriminant. Our discriminant is b squared minus 4ac, and you need to figure out what A, B, and C are and try setting that up. Pause it and then start back up again when you're ready. All right, great. Hopefully you did that. So in this case, A is going to be clearly 2k minus 3, and B a little bit less clearly, but again, if you remember what I said, anything multiplied times x, so that's going to be negative k minus 3, And then c is anything not multiplied times x or x squared. Well, this is a variable, but it's not being multiplied by x or x squared, so that means my c is going to be negative k plus 6. So then when I get my discriminant, it looks like this, negative k minus 3 squared. That's b squared minus 4 times a, 2k minus 3, times c, which is negative k plus 6. Once again, in this case, they're telling me it's tangent, so I make my discriminant equal to 0. And see, sometimes people get confused. They think that these two have something to do with each other, and they have nothing to do with each other. If this problem had said that they meet twice, I'd be making it greater than 0. If it said that they won't touching at all, then I make it less than 0. So, what I want you to do now is see if you can't solve for k. Pause this and start back up again when we're ready, and we'll compare. Okay, so hopefully you did that. If I square this, I'm going to get k squared plus 6k plus 9. And then when I distribute this, I'm going to get negative 8k plus 12. And see now, these two things are going to get multiplied together. And so what I'm going to do here is I'm going to multiply negative 8 times negative k, and I'm going to get 8k squared, and then I'm going to get negative 48k, and then I'm going to start over again and negative 12k, and then I'm going to get the lasts, and I'm going to get plus 72. And I'm not going to forget the stuff that was already here before. And see, now I got a lot of combining like terms to do. Let's see, I've got an 8k and a 1k, so that's going to give me 9k squared. And then I've got a, by the way, what should this be here? That shouldn't be, that should be a k, right? That's a k. So it's 6k plus 9 minus, plus, no, wait a minute, what am I doing here? Oh, that should be this here. Okay, that should be a 6k. 6k. So 6k, let's see, minus 48 minus 12. That's going to be negative 54k. And then plus 81, because I've got 9 and 72. And see, now all I got to do is solve for k. Again, I would probably go to the quadratic formula, but you notice that these are all going to divide by 9. If I divide everything by 9, I get k squared minus 6k plus 9 is equal to 0. And as you probably recognize from the last one, k is going to be minus 3 minus 3. K is going to equal 3. And again, I take a look. They only asked me the one thing. They asked me the value of k. That's what I answered. And again, you'll notice this is a significantly a little bit more difficult problem because of all the k's that they have. But it's actually a little bit less work, and it's worth 5 points. So, it's if you just remember that essentially we did almost the exact same thing for these two problems. I mean, you get to a problem and if it looks kind of scary, you shouldn't panic. You should just try to stick with what you know and do what you can do. Now let's see what kind of the rubric, how that looks. All right, so for the rubric, you'll notice again, I get a point just for making them equal to each other. And then I get another point for forming this three-term quadratic, which means basically getting everything on one side and making it equal to 0. And then I get another method point for using the discriminant and then making it equal to 0. Actually, It doesn't even specify necessarily that it has to be equal to 0, I don't think. But the discriminant, obviously. And then the last method is simplifying and solving their quadratic, okay? And so we've got this. There should be some kind of method in here about how you solve it. Again, hopefully you factored it. If you didn't, you can use your calculator. Make sure you use the quadratic formula. But this one's got another method point. And then the last one is 1. So that's looking for the answer, okay? So what's nice about this is, say for example you screw up this first equation a little bit, but as long as you don't do it too terribly, and you still end up with a 3-term quadratic. And then you could get this point. And then you use discriminant. And then you could get this point. And then, now again, if you had made a mistake, more than likely it's not going to factor out super nicely. But if you use a quadratic formula, you can solve any quadratic. And if you solved your quadratic, you can get another method point. So even though you know that, because like I said, a lot of these times the k is not going to be, square root of 3 plus or minus 4 or something like that. It's going to be some number. But don't give up. Go ahead and solve your quadratic. And in this case, you could get 4 out of 5 points and not even get the right answer. All right, so let's take a look at another one. Here, they've given us 2 quadratics, and what they want us to do is they want us to put us in this form here. Now, I got to tell you that in years gone by, this is an incredibly popular thing to do. I pulled these other questions. This is the other kind of thing. They call it complete the square form. Complete the square form. And we call it vertex form, which is y equals a times x minus h squared plus k. Okay? And where h, k is the vertex, all right, we here call it the vertex form. They will call it all kinds of weird stuff, okay? But it's essentially the same kind of thing. And so basically the methodology we're going to use is, keep in mind, if I want to find the x part of a vertex of a quadratic, if I do the x part is going to equal negative b over 2a. So for example, in this one, it's going to be negative b 2 over 2, and the x part is going to equal 1. And then if I substitute the 1 back in there, I'm going to get the y. Now, if I do the same thing for this one, it's going to be negative 4 over 2, which is going to be equal to negative 2. These are the x parts of the vertex. And as far as method points, if you show that, I think you're going to be in pretty good shape, because the other thing is that you don't really need to do this. If you go to your calculator and you do menu A, and menu A, and then do number 2 polynomials, and then select the 2 degree, and if you plug these both in, you're going to find the vertex for both of these very easily. So again, I would just quickly write down some kind of method for finding the x part of the vertex, and then next to it, then the vertex is going to be 1, 4. And I tell you what, go ahead and pause this. Find the vertex for the second one. X squared plus 4x plus 13. Do menu A, and then the polynomial 2, and then the degree 2. Plug in the coefficients for this polynomial, this quadratic, 1, 4, and 13. And then press enter and go down until you find the vertex, and then start back up again. Okay, so hopefully you did that, and if you did, you hopefully found out that the vertex is, for the second one, is going to be -2, 9. Now, if we're going to write these in vertex form, which is what they want us to do first, then vertex form is going to be A, which in both cases my A's are a 1. So I'll tell you what, we're going to go down here. So y equals, A is a 1, so then it's going to be x minus the x part of my vertex, so it's going to be 1 squared, and then plus 4. Keep in mind, when it's in vertex form, this middle number is going to be the opposite of your x part of your vertex. And then if I do the other one, y equals x, and then this is going to be plus 2, because it's going to be minus, and then a -2 is going to be plus 2, and then plus 9. All right, so now we have put them both into complete the square form. And then they want us to express g of x in the form of f of x plus p plus q. So again, I guess you know what, we probably should go ahead and label these a little better. Let's do this. This first one was f of x. And then this one is g of x. And so what they want us to do is they want us to express g of x in the form of this. So basically what they want me to do is, and again, hopefully you recognize this as being transformation notation, right? In this case, what's happened is we've added a number to the x, that's going to make it go to the left. And then we've added a number at the end, that's going to make it go up, okay? What they want us to do is they want us to tell them basically what happened to this graph to make it this graph. So all we've got to do then is take a look, and what's the difference? How do I get from -1 to +2? Well, I would add 3 to this, right? -1 plus 3 is going to be 2. And then how would I go from 4 to 9? I would add 5 to it, okay? And so if I want to write this in this form, it's basically going to look like this. G of x is equal to f of, and then x plus 3, because that's what I did to this function. I added 3 to the x's, and then plus 5 at the end. And that's going to give, that's the answer to part A, okay? Put it in complete the square forms, and then basically they want to know the transformation that happened from the first one to the second one. And again, if you think about it, if this was the vertex and this is the new vertex, well, clearly what happened is that I went from 1 to -2. That means I went to the right, or I'm sorry, I went to the left by 2 or 3. And the way I go to the left by 3 is by adding 3. And then I went up 5. Okay, so, you know, that's the important part about this one. Okay, so then part B, it says fully describe the transformation that transforms f of x to the graph of g of x. So basically what they want to see is, you know, what's happened here. Well, again, the easiest way to do this is, keep in mind, it's a translation. And so basically what's happened is that, I mean, again, you can tell by looking at this, or you can tell by looking at this, but it's moved to the left, but we can't use the word left. So if you remember, we can use this vector notation, and what would happen is that the 3 to the left, well, that would be a -3 on the top. And the 5 up, that would be a 5 here. Literally, this is the answer to the question part B, okay? If you use words, then you have to say, it's a horizontal, let's save this. It's a horizontal translation of positive 3 along the x, which means along the x-axis. And then we would say that it's a positive 5 vertical shift along the y or parallel to the y. It's a whole lot easier if you use this vector notation. All right, so let's take a look and see what the rubric says about this. And notice they don't even have a spot here for method points. They just want to see the vertex form and vertex form. That's 2 points here. Now I tell you what, if it's me, I'm always going to show some sort of method because quite honestly, this is a little bit unusual. Typically, you have to show something, but in this case, you didn't have to. You had to have this. You had to have this right. And you remember that last question where there's worth 5 points, but you could get 4 method points? Well, see, the problem is, on this question, this problem is worth 4 points by itself, and yet everything has to be exactly correct. So, I mean, and you'll notice how here you can do this. All right, so let's take a look and see what else we got. Oh, yeah, so we got the translation or shift, okay? Don't say the words left or right. You can say along the x-axis, along the y-axis. You can use the word horizontal. You can use the word vertical. But don't say it shifted left or right, and don't say it shifted up or down, because that won't be enough. And like I said, just get comfortable with this vector notation, because literally that's all they want. Okay, let's take a look at another one. Here, we've got a quadratic, 16x squared minus 24x plus 10, and they want us to put it in this form, and you'll notice it's pretty similar to what we would say is vertex form. And so what's happened is it's got a little change, and hopefully you've run across a problem like this before. So basically what we're going to do is we're going to treat it just like we're putting it in vertex form to start. So once again, I'm going to go like this. Let's go here, and I'm going to find the vertex x. So the vertex x is negative b over 2a, which is going to be 24 over 32, which is going to be 3/4. Now, that's going to be the x part of the vertex. And see, then all I'm going to do is go with my calculator and figure out what the y part of the vertex is. The y part of the vertex is going to be 1. So this is going to be 3/4, comma 1. That's our vertex. So if I go to plug this in vertex form, in this case, a is equal to 16. So it's going to be y equals 16. And then it's going to be x minus 3/4, and then plus 1. Now the problem is, you'll notice we don't have it looking like theirs. All right? Now, if you run into a situation like this, where they've got a number times that x on the inside, on the outside, when we write it in our vertex form, it's going to be a perfect square. So if I rewrite this as its equivalent, 4 squared, it's going to look like this. Oops, both those are squared. All right, now, because everything inside here is being squared and the 4 is being squared, I literally can distribute this now. So this ends up being 4x, and when I multiply 4 times negative 3/4, I get negative 3. And so then, if I want to do it in the way they're talking about it, a is going to equal negative 3, and b is going to equal 1. All right, so put it in vertex form. If there's a number on the inside, then this number is going to be a perfect square. Rewrite it as its number squared, and then distribute it. Okay, so in part B, it says that this equation, 16x squared minus 24x plus 10 equals some number, a constant, has exactly one root. All right, now this is similar to what we were doing before with the two equations, only this is just about a quadratic. And so keep in mind, when a quadratic has one root, it's going to touch the x-axis at one point. We could say it's tangent to the x-axis. Do you remember if it was equal to 0, then it was tangent? Well, if a discriminant is equal to 0 of just a quadratic, then it's going to be tangent to the x-axis. If it's greater than 0, it's going to be, if it's greater than 0, it's going to hit the x-axis twice. And if it's less than 0, it's not going to hit the x-axis at all. It'll be up here somewhere. Okay, so there's actually a couple different ways to kind of take a look at this. If you think about it, where is this quadratic right now? It opens up. We know that because the A is positive. The vertex is going to be 3/4, 1. So in the scheme of things, what we're talking about is 3/4, 1. It's going to look something like this. All right? Now, if it's going to only have one root, well, then what's going to happen is that it has to go down by 1. So it's just touching the x-axis at one spot. Now, if you take a look at what we've got here, if this was my k, and it was the number 1, well, now, if I subtract it on both sides, you'll notice that what's going to happen is that it's now going to be 4x minus 3 squared, 0. It's going to be touching the x-axis, right? So that's one way to figure out our k. Another way to figure it out is, like I said, just use the discriminant. If I did the discriminant, it's going to be 16x squared minus 24x plus 10 equals k. And of course, when I make it equal to 0, 16x squared minus 24x minus 10 minus k equals 0. A is equal to 16, and B is equal to negative 24, and C is equal to negative 10 minus k. All right, so what I want you to do is I want you to use the discriminant and make it equal to 0 and prove that if k equals 1, well, find value of k. It should equal 1. Pause it and start back up again when you're ready. Okay, awesome. Hopefully you did that. If you did, it's going to look like this. Negative 24 squared, that's my b, so it's going to be 576 minus 4 times 16. I'm just going to go ahead and write this out. Times 10 minus k equals 0. And when I put the 4 times 16, I'm going to get 64. And so 576 minus 64 times 10 minus k equals 0. 576 minus 640 plus 64k, because I'm just distributing, equals 0. And then, let's see here, this is going to end up being negative 64 And if I subtract it on the other side, it's going to equal negative 64k. K is going to equal 1. All right? So the first thing is that they want to know what k is. Find the value of k, where k is at. Well, actually, you know what? They don't even ask you what k is. They say k is a constant. We know that that is what it is. Then we can go ahead and solve this thing. And again, you could just use your calculator, but if I make this a 1, when I subtract it on both sides, it's going to be 16x squared minus 24x, and then plus 9 equals 0. And why don't you go ahead and use your calculator? I mean, if I'm solving this one, I'm going to do b squared, or I'm sorry, negative b, plus or minus b squared minus 4 times 16 times 9, all divided by 2 times 16. Plug that in your calculator and tell me what x is going to be. Pause it and start back up again when you're ready. Okay, hopefully you did that, and if you did, you found out that it was 3/4, and you noticed there was only the one of them. And quite honestly, we didn't really even have to figure all that out, because if it shifted down by 1, by subtracting the 1, it would cause the whole thing to shift. This part of the x, part of the vertex, wouldn't have changed. That's the root, that's the 0, and that's our answer. Find the root. So let's take a look and see what the rubric says. All right, so first part, basically, we're putting it in vertex form. A is -3, B is 1. All right, so, we're getting it set up. That's worth 2 points by itself, okay? Now, you'll notice how either by inspection, you notice how we did with the graph? We figured out the graph, and we figured all you had to do was subtract 1, and that's where we got the 1. Or we could use the discriminant and solved it. And this with the www things, make sure you have to have, it has to show working. That makes sense. And then you'll notice they got the root of 3/4, and again, that's worth another point. Okay, so this one's very similar to one of the early ones that we did today. It's not a quadratic, but it should work out pretty much the same way. What I want you to do is I want you to try to solve this. Go ahead and pause it, at least do part A, and then see what you can get, and then start back up again when you're ready. Okay, so hopefully you did that. So let's take a look here. This is a little twisty, but basically it's similar in the problem, like we said. You'll notice this is y, and what I can do is take this and what y is equal and put it right there. So let's try that. It's now going to say x times mx plus c is equal to 16. Now notice they say given the line is tangent, express m in terms of c. That means we need to get m by itself, and there needs to be c's on the other side. So let's go ahead and distribute this. When I do x times mx, I'm going to get mx squared, and then times c, it's going to be plus cx equals 16. And then when I get it all on one side, I got mx squared plus cx minus 16 is equal to 0. Now, I get it's not a really awesome quadratic because there's so many letters, but the thing is, if I use discriminant now, and because they tell me it's tangent, I know I can make it equal to 0. So if it's discriminant, that's going to be A is going to be equal to M, and B is going to equal to C, and C is equal to negative 16. So it's going to look like this. C squared minus 4 times M times negative 16 is equal to 0. Well, so then when I multiply this, I get C squared plus 64 M equal to 0. Now again, express M in terms of C. Get M by itself. So that means I'm going to have to subtract the C squared. 64M is equal to negative C squared. And then what I have to do is divide by 64. M is going to equal negative C squared over 64. I have now expressed M in terms of C. Now, in part B, what they want us to do is they want to say, hey, you know what? Make that M a negative 4. And so we could start all over here at the beginning, but I want you to notice we're going to do the same kind of thing. It's intersecting. We're going to make these two equal to each other. So what we can do is actually even go all the way down to here, actually down here, or even down here, now that I see it, and make this M a negative 4. So now it's going to say, let's go over here, C squared, and then it's going to be plus 64 times negative 4, and then it's going to be greater than, because it's intersecting at 2 points, 0. Now, 4 times 64, that's going to be C squared minus 256 is greater than 0. Now, I got to tell you, this is probably one of the easiest mistakes to make right now. This is a quadratic inequality. And people, you've done a lot of work, and then you get to this point, and what people want to do is they want to add 256 to both sides, and they want to square root both sides, and then say the answer is plus or minus or equal to or whatever. But the problem is that quadratic inequalities work a little bit different. What I need to do is I need to find the zeros. In fact, you'll notice that this factors. This is a difference of two squares. 256 is a perfect square, and so if I were to go like this, C minus 16, and then C plus 16, and make that greater than 0. All right, now I can find the x-intercepts. The x-intercepts are 16 and negative 16. Clearly, this guy opens up because A is positive. And what I need to figure out is whether my answers are between these two x-intercepts or outside these x-intercepts. And so what I do is I'm going to take a look here at 0 and plug it in here, and then find out if it's true. Now you'll notice that if I make this a 0, negative 256 is not greater than 0. So my answers are not between these two. My answers, my C's if you will, are going to be greater than 16, or my C's are going to be less than negative 16. When you have a quadratic inequality, you have to find the zeros, and your answers are either going to be between them or outside of them. And it's always going to be that way. Okay, let's take a look and see what the rubric says. So you see here where they just did the same thing. They put this in, we solved it, we got this quadratic, we used the discriminant, and we get m by itself. So really, you've got to be able to do this. That's worth a point. And again, that's just substitution. Okay? And then using discriminant, that's a method point. And then getting this, that's going to be the answer. And then you'll notice for part B, all that happens is that they go ahead and plug this in. Here we got the same thing. And really, I mean, they take this and we go right to this, okay? So we go into the discriminant. We need to get this to get the method point. All right? You could start at the very beginning, or you could start where we did, pretty far at the end. And then they need two answers. And see, your answer is either greater than 16 or they're less than 16. Okay, so I hope this has been helpful. I appreciate you watching, and I'm signing off for now. Have a great day.